A square circumscribes a circle. Alright, so you got to stop straight away.
So this question's going to be in the test.
Okay, now, the reason why I'm giving you these kinds of problems is for the exact purpose that you practice the kinds of problem-solving strategies that will be useful to you when you're doing that working mathematically section at the very end of the test. Will you get these exact questions? I have no idea, probably not, but all the strategies that we've worked through here, I can guarantee will be useful in approaching the questions you will get, okay? So, there's enough similarities I think that it'll be useful to you, that's the idea. Now, as usual, I've drawn the diagram that they've given us, that's nice, okay? And then they introduce this weird language. A square circumscribes. That's an awkward word. Now, all it means is it goes around, okay? And you can see on the diagram what that means. The square, all of its edges, they press onto the circle. There's no extra space. It's not like something like this, for instance.
What?
There's a circle inside a square, right? But the square isn't pressing on all sides, so it's not the same kind of relationship. Now, let's keep going through the question. It's a radius of 40 centimeters, so if you put in your center there, okay, from the center to the circumference. Wow, this pen is dying. Let's get a new one. That's 40 centimeters. Okay. Now that's just the, hold on. Yeah, radius. Okay, now it's not diameter, so be careful. You got to watch out for your language there. Okay. A point is chosen at random within the square. Okay, so somewhere in where I've drawn, they pick a point, like there, or there, or there, wherever, we don't know where. Find the probability. Okay, we've done a few of these questions already. What should I write now as soon as I hear or see the word probability? What can I say? What is probability? Yeah.
Surface area
It is something over something. I heard that, right? Ah, good. Sample space is there, but it's actually the denominator. You're dividing by sample space.
Possible outcome.
So that's all the possible outcomes. What do I want on the top? Not the possible ones. Well, it is with an F. Favorable. Favorable. As in, that's the ones that we're interested in. Favorable outcomes. What we want over what's possible. Okay. Find the probability that the chosen point is not within the circle. And then it talks about the answer later on and the format they wanted. Okay, so let's stop. Let's have a look. Now, where are the favorable outcomes? We can actually put this on our diagram, right? They want it to be within the circle or not within the circle? They want it outside, don't they? So I can shade this in just to give myself a bit of a visual cue. Okay, so I'm going to shade that part. Looks like this. There, or there. Yeah, good. Okay, so by doing this, you can sort of give yourself a better idea of what you need to calculate. Okay, so in order to work out that shaded area, let me actually write out some steps myself. Okay, number one, I'm going to have to work out the area of the square. Yes. Number two, I'm going to have to work out the area of the circle that's inside. Okay. Number three, I'm going to have to work out the difference. That's the shaded part. Yeah. And then lastly, I'm going to use that to work out the probability. Okay? So, let's do this one by one. Go through the steps. What's the area of the square? What do you need to work out a square's area? What kind of information do you need?
One side of it.
I need a side, don't I? And I only need one side, because once I've got one, I've got all of them, don't I? Okay.
80.
So now, what is the answer? What is this? It's 80, but how can you tell that it's 80? Where does that number come from? Yeah. Yeah, go ahead, Lucas.
Because it's 40 from the middle to the side, so the other side must be 40 as well.
Good, perfect. So that's the great thing about the radius, right? That since it's the distance from the center to the circumference, it's always the distance from the center to the circumference. So that must be 40 as well. Therefore, 80 is correct. Okay. So therefore, the area of the square, you don't need much working out for this, do you? You can actually get your calculator out and you can work it out straight away. What do I do with this 80 to get the area of the square? What kind of shape is this again? It's a square. So you take this and you square it, don't you? It's 80 squared. Yeah, I did trick you. Sorry. That's hold on. That's not 1600. It's what's 8 times 8? 8 squared?
64.
64.
So 640.
And there's going to be, now there's a 0 there, so I've got to multiply that again. Alright, what have we established so far?
Yeah.
We've got an area. Okay,
Right.
good. That was the area of the square. We need more than that though. We need the area of the circle, don't we? How do I do that? Circumference will tell me a distance, but I want an area, like a shaded thing. Now, circumference is 2 pi r, right? Circumference.
Don't forget to
That's 2 pi r. The formula for area is very, very similar, but it's different. Yeah, do you remember it? Good. Area equals pi r squared. So that too is just, if you like, it's just moved, okay? Now, do you remember how we remembered which one's area?
is always measured in squared.
Yeah, it's like centimeters squared or meters squared or something like that. There's always a squared. Okay, so that's how I remember which one's which. Now, what do we need to work out the area? Then we just need the radius, don't we? But that's the first piece of information we got. So, what's the area of the circle? It'll be color. Pi times the radius, 40, squared. Okay, what's 40 squared?
40 times 40.
40 times 40. 4 times 4 is 16.
No, it's 3.
160, 1,600.
I'm pretty sure it'll be 1600. You can check it out on your calculator. Okay. I've got the 4 and the 4. They become 16.
Oh, wait, no.
And then I've got the zeros. They become...
You're right.
Cool. Thank you. I feel very validated. That's great. Okay. Now, I want this, the difference, because that's what the shaded part is. Isn't it? That's the shaded part. So it's the square, take away the circle. I've hollowed it out if you like. Okay. So therefore, it's going to be this minus this. The square minus the circle. That's going to be the shaded part.
The square.
Is that okay? Square minus the circle? Yeah. Alright, now I've got all the pieces I need to work out this part. The favourable outcomes, that's the part that I want. Right? And we said that's the shaded area. That's the one I just worked out. 6,400 minus 1,600 pi. Now, I know you could get your calculator out and work out what this is, okay? But that's going to mean I'm going to have to approximate, and I like to approximate right at the very end. It's more accurate that way, okay? That's the favourable outcomes. What's the sample space?
The area.
It's everything that can possibly happen. So come back to the question. It says, a point is chosen at random where? But where are they chosen? What's the
Within
possible?
the square.
Well, that's right. So it's somewhere in here. So therefore, I need to put in the area of the square.
Yeah.
Right? This is the total number of places I could possibly be. Okay? Or the area that corresponds to those. So that's it. That's the fraction. But they do want us to approximate. So you'll need your calculator there. Okay. Now, oh, did I let my calculator or something? Oh, yeah, that's right. Okay, good. Now, before I punch this into my calculator, I'm just going to simplify this a little bit, and factorizing, which we learnt under algebra, that's going to help us here. Okay, so have a look at the numerator for me. Can we factorize this?
Yeah.
What can we take out?
The pi.
We can take out zeros to start with. Let me do that. So I'll get 64, and I'll get 16 pi. Can we take out anything else?
Can I take the bottom 0, 0?
I will in a second, but can I factorize out anything here? 64 and 16. Can I take anything out? Now, I'll admit the numbers are pretty big, but if you check with your calculator, I'm pretty sure that 64 divided by 16 is 4.
Oh yeah.
Is that right?
Yeah.
Want to check out? Okay. So with these numbers, I can take out another factor of 16. I'll get this. 1,600 now at the front. I'll have 4 of these, and I'll have 1 of these. There you go. Okay. So the reason why this is good is because now I can make these numbers all really small. I can cancel that 1,600, and I'll just be left with 4 down the bottom. Much nicer, smaller numbers. Okay.
What's that? What was that? Sorry.
Both of you, really. I got 4 minus pi on 4. Okay. Now, by the way, quick question. What are the units on this thing? What are the units, yeah?
Centimeters.
Now, bit of a trick question. Trick question.
That's a good point.
I started with centimeters, didn't I? Everything was in centimeters. These are areas, so I guess these are square centimeters. But
Mil squared.
this is a probability. It's not a length. It's not a measurement. It's not an area. There are no units. It's just that's it, right? If I said to you, you know, what's the probability of oh, I'm poor today. I don't have any coins on me. What's the probability of, you know, flipping heads or tails? You don't say like half a centimeter or 30, you know, meters, whatever. You just say 50%, 50-50, half. So there you go. That's that. Now to approximate, how far do they want us to approximate it? Does it say? What's the approximation they ask for? We've done approximation on a number of skills. Do you remember how to do this? They want 2 decimal places. So get your calculator out, okay? And let's punch this in and we're going to get some weirdo decimals, okay? So let's do this. Okay, someone got the answer? And check if you get the same thing as me. Someone got it? Anyone got it? I'll give you a clue. It starts with 0 point. Anyone?
Oh wait, yes, wait, I've
Yep.
got it. It is-
0.2.
No, stop.
2, 1, 4, 6,
0,
0, 1. Okay, and I'm going to stop there. Now the reason why I can stop is
I've
that
got 1 pi.
they only want 2 decimal places. Don't they, right? Can you stop that? Come on, that's annoying.
0.21.
No,
So I just want the 2 and the 1,
it's
don't
a
I?
really good fan. And it smells nice too, so.
Okay, there you go. I'm done. That's the answer.
That's confusing.
So let me just review, because there was a lot of steps there. It is confusing, okay? You have to start by getting a picture for yourself, okay? You can't do anything accurately unless you have a picture there, if it's a geometry type question, okay? Then they said it's a probability, so then I knew I had a fraction involved. And then I had to work out what are the bits that are going to go into the fraction. That's what this is about, okay? And then you put it all together, your number hops out the end, all right?